Yeah. Okay. That's a very good T-shirt, Roshan, and we will promote the scientific temper along with the sportsmanship spirit. You know our hashtag, right? STEAMS, STEAMS. So all-round development along with sportsmanship. So you are a sports person. You are a sportsman athlete. We'll have a scientific temper as well. So we also have this concept of hashtag of Sheldon can play sports. So scientific temper along with sportsmanship spirit. So now today we are going to discuss about a very hot topic called RSI. RSI is recursively self-improving programming constructs.
Okay.
Yeah. So you have been associated with programming languages, and you know the some concepts. Even if you don't know the concept, is still fine, because I have prepared this presentation in a way that's very democratic and it does not have any prior literature knowledge requirement. So we'll go by that. So you understand the term RSI, right? RSI is in sense a recursively self-improving programming construct. So this recursively self-improving concept need not be applied only for programming. It can be applied for any software. It can be applied for any process, any construct. So it's not confined for programming alone. So here I'm taking programming because we would like to use RSI-based programming constructs for our projects. We are going to innovate in this space. So that's why I gave the reference of Navi language created by James Cameron. That's a pretty awesome language. So it takes a lot of effort to create a language. It's not a simple task to create a language. Like Shakespeare invented so many words. I made English so famous. And just if you take the example of English, it has evolved over the ages from Old English to medieval English to modern English. So just one language. So creation of a new language is not a simple task, and James Cameron has done that. So we have taken inspiration from James Cameron and other linguist enthusiasts who have created languages like Klingon. That's a Superman language. So so now we are going to create a language in a programming space, programming construct. So we are going to mimic like a fraction of what Dennis Ritchie did years ago when he invented a middle level language called C. So we are just to a small extent we are trying to achieve his feat and what James Cameron has done. So now let's go to the agenda. See, the agenda is always the same. The reason why I'm following the same template for all our presentation is you have a uniformity in a thought process, and also to make it very a robust way in ideation. So what happens is this becomes a streamlined thought process for me. So I go with the problem definition, then solution, then principles involved, the creation of the solution, the future expansion, and further expansion. So this becomes a good template for me for ideation. And it has worked pretty well because using the same template, I've introduced 4 concepts. So I don't use the term I, it's we, because just because I have good audience in terms of the swans, I am able to ideate, and we are creating concepts. So what is... Okay, there's a... We'll correct it online. So I did not change the problem with the existing programming constructs, the electric power construction. This is the previous concept.
Also, the theme of the agenda, it provides a systematic approach to the topic, like how things it is going, and it is interconnected. So it is good actually.
Yeah, it's all interconnected. See, everything is every field, every domain is interconnected. Mathematics is the mother of all sciences. Everything is interconnected. Even for arts, mathematics is not only the mother of all sciences; it's a mother of all arts as well.
Yeah.
Music is nothing but mathematics. If you are a good musician, it means you're good at mathematics.
Okay.
People tend to go away from mathematics, they're thinking that, oh, we are not good at mathematics, but they end up being good musicians. So
Yeah.
Hans Zimmer or A. Rahman or Yanni or Andrew Ryu, they are all good mathematicians.
Okay.
So the problem with existing programming constructs are as follows. The complexity of semantics decreases the speed of operation. So I'll tell you what is the complexity of semantics. So you have assembly language,
Yeah.
middle level language. Okay,
Yeah.
language closer to hardware, that's your assembly language, and microkernel, you call that as firmware, things, stuff like that. So that's closer to hardware. And then
Yeah.
you have middle level languages like C, Objective-C, and those middle level languages. Then okay, C++ is also to a certain extent middle level language, but not exactly. Then you have high level languages like your heavily semantic oriented language like Java, C hash, and all those things. And also we have a demarcation between interpreted languages and compiled languages. I hope you know the difference, right? Difference
Yes.
between,
Yes.
yeah. Interpreted language in
Interpreter,
sense,
compilers are there.
interpreter, I'll tell you the difference. Interpreter is in the sense, I ask you a question, you reply to me immediately. Then I ask you the next question, you reply to me immediately. A compiler would be, I'll ask you 10 questions. You think in your mind the answers for all the 10 questions. Then you answer me back after some time for the 10 questions. So that's a simple analogy of difference between an interpreter and interpreter-based language and a compiled language. So why do we need interpreted language? So we started with interpreted language. BASIC was an interpreted language, the beginner's all-purpose symbolic instruction code. That was the first, very first, very famous language. So that's an interpreted language. Python is an interpreted language. That's why we have a interpreter for Python. Though we have a compiled version, or we create using PyCharm, we create a kind of a pickle kind of a thing. A pickle in the sense a saved state. So we have that Python. Java is an interpreted language. The reason why we have Java as an interpreted language is they want platform independence. It can run on any hardware. So they have something called the bytecode, and it's they have the platform independence, and that's why they want the interpreted language. The problem with interpreted languages, they're not that fast, and there's also a problem with the compiled language because once you increase the complexity of the semantics, the speed of operation also reduces.
Yes.
So Java is not as fast as C++, and C++ is not as fast as C. Because of the instructions involved, and it's like you have a game of whispering the truth, right? You have this first person whispering something to the next person, and the next person he just passes on. So what happens is with high level languages, this passage of information, that is translation to lower complex semantics, reduces the speed. That's what has happened. So it's all abstract syntax tree and directed acyclic graphs. I'll explain about that later, but that is the concept. So the higher complexity of your semantics, the speed of operation is reduced. And compiler optimization is not achieved in a true sense. In the sense, you have compiler optimization, but what happens is there are data integrity problems. See, there are a lot of spelling mistakes there. Okay, I guess I was sleeping when I wrote this. Okay, I was half sleepy. But anyway, there are a lot of the problems with compiler optimization as well. Even if you want to optimize compilation, you know the compiler optimization problems, right? The data read problems and data read and write problems.
Correct.
Why do we use the volatile? Why do we use volatile and other such constructs?
So that like it can compile the data as per the instructions provided by the
It does not
language.
go by a optimized approach of data read and write. In a sense, I'll give you an analogy. Every day the milk vendor comes to your house at 8 a.m.
Yeah.
So you optimized your schedule for his arrival. So you go to office at 8:30 a.m. So you know that
Yes.
the milk vendor always comes at 8 a.m. and you go to office at 8:30 a.m. But one fine day, the milk vendor, due to some of his personal schedule conflicts, he came at 9 a.m.
Okay.
So what happened? You missed your milk supply for that particular day. You went to office at 8:30, but you missed the milk supply. So that is what compiler optimization does. So compiler optimization, what it does, it knows that the milk vendor comes at 8 a.m. every day, and it optimized your activity of going to office to 8:30 a.m. But we will have to avoid that by having a flexible schedule for you. You will inform your manager saying that I will come to office only after getting my milk supply. So that's a volatile construct. So you introduce volatile and you say that you will have the data read and write operation as and when it's available, and not with a pre-conceived and premeditated approach, where like how the milk vendor used to come at 8 a.m. every day. So now there are problems with data integrity when you do the compiler optimization. So compiler design is nothing but forming your abstract syntax tree and directed acyclic graphs and having phases of pre-processed directive, parsing, and relocation of your objects and linking of symbols. So this is the compilation process. I don't want to elaborate about the interpretation process, but that's pretty simple. Interpretation is pretty simple. Compilation is difficult. The reason why they have compiled languages is they could have more complexity in terms of their semantic associations, and also in terms of tokens, and also in terms of a few other concepts which cannot be brought in an interpreted language. But there are trade-offs between interpreted language and compiled language. We'll discuss about that. And now we are trying to bring in event-based generalization to programming construct. So we talked about generalization a lot in our artificial general intelligence concepts. You know, the classical example of a computer going to Hyderabad from Bangalore and trying to navigate, right? I gave that example earlier.
Yes.
So you go to Hyderabad, you are able to navigate properly because you are good at generalization. A computer cannot do the same way because it's not good at generalization. Similarly, we'll have to bring event-based generalization to our constructs, programming constructs, and it should recursively improve itself. How do you bring an event-based generalization into a static construct? So you have pre-processed directive, you have parsing, you have the memory associations, and you have the text part, that is the semantic part, and then you have the data part, and it's all interacting and it's going in a static manner. Though we have some memory allocation in a dynamic manner and some dynamism into the system, but it's not always. People don't recommend dynamism in an embedded system because it's mission critical, and even in life in healthcare it's life critical. So people don't try to bring in dynamism here. That's because of the constraints of your compiled languages, or for that interpreted language. So now we are going to try to bring an event-based generalization, which are not going to cause any problems.
Okay.
Problems like race conditions, problems like data integrity problems, a recursive function will have data integrity problems. I'll give you an example. What is recursion? Recursion is a common function. Let's say you will have to Yeah, you will have to cook idli and dosa.
Okay.
Okay, so the recursive function is batter. But the batter is different for idli and dosa. For dosa, you'll have to make it a bit sour. You cannot have the same batter which you do for idli.
Correct.
So that is the kind of recursion. What happens is people in a recursive function, what happens is if your design is improper, you will use the same batter for dosa and idli. So it won't work for dosa. Your dosa won't be good. That is you have data integrity problems.
Yes.
So this is a simple example of having a non-recursive function. I did that activity. My very first activity when I joined Bosch was removing all the recursive functions in the whole software and making it non-recursive by use of passing it through the stack, passing it as local variable. So once you pass to the stack, you'll have a copy and the data integrity problem is solved. So for this, I worked continuously for 36 hours without a loop break. Because imagine
Okay.
you are changing all the recursive functions in the whole software, in the entire 2 MB software. At that time, 2 MB was quite big. So 2 MB code base in your Flash, you are changing all the recursive functions. And you have to be very careful. You'll have to pass it properly at the stack and all those things. You have to be very careful. It's not that I'm just doing some repetitive mindless task for 36 hours flat. I was doing something very serious there. We could avoid all those
Okay.
things. We could avoid all those things by our event-based generalization. So that was a very good reminder for me to. I just thought about it recently. Like there was some post about productivity and creativity and all those things. There were a lot of discussion going on. Then I recollected what happened early in my career when I was working for 36 hours flat, and people even called me Terminator. People called me Terminator because I was working like a machine. Terminator Judgment Day. Okay, so now we will try to bring in event-based generalization using our RSI concept, and Seed AI is a new advent. There's an organization, Seed, who are trying to
Okay.
innovate in this space by bringing recursively self-improving constructs, not only in programming but in other areas as well.
So is it interlinked with our Swarm AI
Yeah, 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 yeah.
platform?
Everything's interlinked. That's a beauty. Every field is interlinked. Every domain is interlinked. Every concept is interlinked. So calculations are error prone due to the static nature of the semantics. I told you what is the static nature of semantics. You have a static allocation. Let's say variable A will have its own static allocation, will have its own constructs, will have it in case you're using paging concepts, it will have its own paging concept. And paging concept is nothing but trying to bring in as much information from your secondary storage to your primary storage, which is faster. That's simple paging. We will try to optimize in all those concepts and try to reduce on the cost of cache. Cache is very costly. RAM is very costly. So we will try to reduce the cost as well with our programming constructs. So why do they have these paging and all these elaborate memory map, memory management concepts? It's because of the lack of complexity of your programming language.
Okay.
So if you're dealing only with the assembly language, then you need not worry about programming construct, and you just have a very solid hardware and everything works well. But that's not the way we want to work, because as a learning assembly language and working with assembly language is not good,
Correct.
because you'll have to unnecessarily keep in mind a lot of stuff.
Yes.
It's like memorizing your telephone directory.
Yeah.
Okay, do you memorize your telephone directory, or you just refer your telephone directory to call someone?
Like few of the important numbers, which is
A
like
few numbers,
known
okay.
that.
In emergency cases, you will have a few numbers. Yeah, that's fine.
Yeah.
So similarly, your assembly language is like that. It's your telephone directory. Then we went slightly higher up with the middle level language and then higher level language. In a higher level language, you need not remember anything. Just type something, it will autocorrect. Okay, that's that's the advancement we are bringing. So because we are concentrating only on logic, not on semantics.
Okay.
We are concentrating only on algorithm. So as and when you go and hire up, like we concentrate on data structures and algorithms, and not on these actual semantics and how they work and stuff. It's not required for us. You just concentrate on data structure, and even after a certain extent, you don't even concentrate on data structures. You just have to concentrate on algorithm, and the system will automatically choose your the data structure it has to operate with.
Okay.
So you just concentrate on algorithm and plain logic. So now the calculations are error prone due to the static nature of the semantics. So these are the problems. Okay, and what are we innovating here? We are innovating using seed AI powered by particle swarm optimization. I guess I shared a paper of PSO in LinkedIn. I hope you have seen that.
Yes.
So PSO, what it does is it avoids getting stuck in a local minima. So I explained about gradient descent the other day, right? The local minima, global minima, and all those things. So local minima is a trough which we encounter when we try to go to the global minima. So I'll give an analogy. You have to go to you're running a ultra marathon, and your end destination has a resting place. So that is your ultimate global minima, resting place. But you have resting spots, resting spaces at every 10 kilometers. Every 10 kilometers, you have a resting space. So that is your local minima. But for someone who does not know the format of the ultra marathon, or if he doesn't know what's going on, he or she will go to the first resting space and think that the marathon is over, and she or he will stop the marathon, stop running.
Okay.
So that is like being stuck in your local minima. But a seasoned runner like you will know that, okay, ultra marathon is 100 kilometers long. I should not stop after 10 kilometers. And you will continue traversing until you find your global minima, which is your final ultimate resting space. So this is exactly what particle swarm optimization does. It avoids getting stuck in local minima. And it's based on Swarm AI. Swarm AI again is like collective intelligence. We know about it. And we have an AGI engine, generalizing self-correcting programming language, reducing the cost function recursively. So we are introducing cost function into programming constructs. It's pretty interesting. And we have some concepts of evolutionary programming, genetic algorithms, and stuff like that. I'll discuss about it in the next slide. We are going to bring those innovations as well.
Okay.
Okay. Now, what is the solution scape and avenue? Seed AI based on PSO, that is particle swarm optimization based Swarm AI, powering an AGI engine to create a generalizing, self-correcting programming language, reducing the cost function recursively. So we are bringing in generalization as well. It's not just self-correcting. So the seed organization and other organizations, they're just doing self-correction. Recursively self-correcting, but we are bringing an additional concept of generalization. So I'll tell you what is generalization. Okay, we'll go back to the same milk vendor analogy. Every day you find a milk vendor, the same milk vendor, and one fine day you find another milk vendor from the same organization. You should generalize the fact that he's from the same organization, and you should accept milk from him or her, and avoid any conflict. If you are not good at generalization, let's say you are a robot. You are a robot, and you don't know generalization, and you don't know that the person is from the same organization who supplies milk for you. What you will do is you will go and fight with him. You will go and fight with him and rebuke him, saying that, okay, you are not my vendor, and I'm going to the police. something like that. So that is a lack of generalization. So that will happen. What will happen is you'll have some kind of race conditions or something else in your software, in your programming language, when you're not able to generalize, even when it's self-correcting. Self-correcting is fine. Self-correcting is you're reducing error, but it's you're not able to generalize. So we are going to bring in the additional concept of generalization as well. And we are using the existing DAG constructs. DAG is directed acyclic graphs.
Okay.
So that is part of your compiler design. They have something called abstract syntax tree. That was an older convention. Now they call it directed acyclic graph. So what it does is, you have, okay, I'll give you an analogy in terms of knowledge graphs. So we discussed about knowledge graphs, and you searched AnaVJ in your workstation in a Google window, and it showed the address of AnaVJ in the right hand side corner in a very presentable format.
Yes.
So that is knowledge graph in the machine learning and artificial intelligence parlance. The same knowledge graph in compiler design parlance, to a crude extent, in a very crude fashion, is directed acyclic graphs. So it is like gathering information and constructs in a way, in a presentable manner. Like you have your family tree. Let's say you have your family tree. Yeah. By reading the family tree, you can easily make out the associations and the relations of different members of your family. So that's why you form a family tree. Or if you just write all the names in a haphazard manner in some random location, will you be able to make any association? No. So the directed acyclic graphs is doing that for semantic construction and compiler design. Okay. So if you say compiler design, it's not something rocket science or something. It's just semantic association and parsing and preprocessed directive form in a way which is fast enough and with some compiler optimization. Compiler design is not tough. And we are trying to improve relocation of objects and linking of symbols concepts. So what is relocation of objects? You have a single file like Roshan.c. In Roshan.c or Roshan.cpp or something, or Roshan. What is the extension for Java? Is it .java? Okay. Anyway, Roshan.c, if you're compiling and you get an object file out of it. What is an object file? It is a kind of memory association, and it's kind of a binary code which a machine understands. You have written in English language. Yes. And the object, it goes to the object code, and that's the object language. So you will have many objects. You have a big project. You will have 10 different projects, 10 different files, and you want to associate all the objects into one enclosure. So that is the relocation of your objects. And you will have symbols, in the sense, you will have, I'll give you an analogy. You have a label for, you have a packaging assembly line. You package your product. Let's say you create merchandise for sports equipment. Okay. Shin guard or something. You create shin guard. The first step is you like in the different stages of the assembly line. You do parts of the creation of the shin guard, and the last step would be labeling it. Labeling the if it has some parameters or something. If let's say if it's a food industry, you label the ingredients and the calories and all those stuff, you label it. So that is your symbol. What happened was you had created the symbol right from the start. So you have the label besides you right from the start of your assembly line, but you're placing the symbol only at the end. Yes. So that is the advantage of linking of symbols, which the programming the compiler gives to the users. So you use a lot of symbols in your modules, and you never know where it's coming from. You just use a lot of symbols, and in the final stage, you are linking all these things together. It's like assembling. It's like integration. of different models. So it is like assembling. So we'll improve on these concepts of relocation of objects and linking of symbols. And with the symbol table, with just a symbol, you'll have symbol files. Like you'll have symbol files like you call it ETF or for debugging they use symbol files, right?
Yes.
I just forgot the extension. So you will have executable ELF. Sorry, not ETF. ELF. So you'll have executable linker format. The reason why we have an executable linker format is for us to debug. So you have all the symbols, you have all the constructs of the software, and you do debugging if there is any issues. You will get the call stack. A call stack, in a sense, the snapshot of the stack when a call is made to a function. So that's all call stack. So with that, you will understand how it's working, the flow of operation and stuff like that. So you will have this executable linker format. So we will try to innovate on these spaces, the improved relocation of objects and linking of symbols. Concepts which is slightly complex, and there's some problems with respect to generalization and event-based handling of programming constructs.
Okay.
And what do we have in place? One moment.
Sure.
Okay, I have six minutes before our Zoom gets disconnected. So I'll plan it. I'll complete this slide and then we will connect again.
Okay.
We'll create another meeting. So because I want some discussion going on, because this is quite an interesting topic. I don't want to just rush. So what are the principles involved? Primary principle, working principle, guiding principle, and scope of expansion. It's going to be the same for all our ideation process. So we are going to have a seed AI powered PSO based Swarm AI. Okay, it's a very big jargon, but anyway, you understand all the concepts. Seed AI, you understand, that's a recursion. Swarm PSO, you understand, particle swarm optimization. I gave you the analogy of your ultra marathon. And
yes.
Swarm AI, you know, it's a collective intelligence. You can take the analogy of supreme soul and individual souls. That's collective intelligence.
Okay.
And you are the primary principle here is seed AI. That's given by the seed organization. That's an organization doing research on this. And working principle is going to be a particles swarm optimization. And we are using the existing DAG concepts. We are not going away from DAG. The DAG is good. DAG is a direct acyclic graph. That's the knowledge graph equivalent in your compiler design. And we are going to add event-based semantic adjustment mechanisms. We'll discuss about that. And what is the guiding principle? We are using Swarm AI, powering an AGI engine to create a generalizing self-correcting programming language, reducing the cost function recursively. And the one of the many applications is going to be your RSI, recursively self-improving construct. So I'm not saying recursively self-improving programming language. We don't want to confine for programming language alone.
Yeah.
And what is the creation of the solution? It's a new paradigm in semantic construction and event handling and responding mechanism by means of self-correcting semantic system created by seed-based on PSO-based Swarm AI powering on AGI and AGI system. Okay, there's some problem with sentence construction. I have sleepy, I guess. I'll correct it. And less concepts involved and avoidance of complex relocation and linking concepts. I discussed about what is the relocation, what is linking. And avoidance of parsing and preprocessor directives. Okay, this is an innovation. We are going to avoid parsing. We are going to avoid preprocessor directives. And avoidance of need of interpretation-based system, as we are bringing the dynamism of an interpreted language to compiled language. Okay, there are some trade-offs between interpreted and compiled language. I'll give you a list of the language, their constructs, their memory management problems, and all the steps. Then we'll decide how we are going to go about. And dynamic semantic construction based on events and feedback to reduce the cost function. Yeah. So dynamic semantics, that's going to be pretty interesting. Dynamic semantic construction, since your constructs keep on changing. Hi, Rosh. Yeah. There was a problem with my network. So Zoom is awesome. Zoom is pretty awesome. See, the recording did not stop.
Yes, correct.
The recording is continuing. It's all pretty awesome. So I appreciate Zoom. Okay, now we'll go back to sharing a screen. And I guess now I have another 40 minutes. Zoom is pretty awesome. So let's share. I'll go by current. Okay, you got it right.
Yes.
New paradigms in semantic construction and event handling. Okay, I talked about this. Okay, the final was dynamic semantic construction. Dynamic semantic construction is going to be pretty interesting because you'll have programming constructs which are dynamically changing. You will not have a fixed programming construct. And what is the current tech usage and future expansion? RSI, we are going to use it currently. And future is AGI based humanoids. You know humanoids, right?
Yes, like the robots which can perform the task of human beings.
Humans. It's been for a long time, right from the movie iRobot, robot, or even before that.
Yeah.
So humanoids and better behavioral modeling. So model-based development is having some problems in terms of bringing into programming constructs. So you have your model-based development generating software, programming languages. You generate some code, but that code is not optimized.
Yeah.
Because the way the behavioral model thinks is not in terms of